Let's see displacement in 2 dimension. So in 2 dimension, we will have 2 axes, an x and a y axis. So remember that a vector can be represented in 2 components vectors. So if this is a vector at an angle of theta, so this vector can be represented in 2 perpendicular components, which is one direction is a y direction, and it is, if this vector is let's suppose r, so the vertical component would be r sine of theta, and this one will be r cosine of theta by simple trigonometry. Okay, and now we can represent a vector using a column vector with x and y component. So let's suppose we have a vector over here at point P, okay, and from point P it goes to point Q, another point over here. Let's suppose this is a boat. Okay, the boat has to travel to the point Q, so it can proceed firstly in this direction to the east, and then it can go towards the south direction. So the boat can do the following. Okay, so let's suppose this is 2 kilometers. So the boat would travel over here, so root of 2, and over here root of 2, and then will reach its destination at Q. Okay, let's suppose the coordinates of P are xp and yp, the coordinates of Q are xq and yq. Okay, so the numbers now to represent the column vectors, we have to take this direction as a positive y direction and this direction as a positive x direction. So now the PQ vectors is represented by the component x and y. So how much it goes in the x direction is root of 2, and how much it goes the y direction, so it is negative root of 2. Okay, and it is in kilometers. So the boat has traveled root of 2 kilometers east and root of 2 kilometers towards the south. Okay, so in the opposite direction of y, that is why we have to put a negative sign over here. So we can write a vector as a column vector, which is given as xq minus xp, yq minus yp by the coordinates. Or, so this is in column vector, column form, or in row form. So the row form is xq minus xp, comma, yq minus yp. So this is in row form. Okay, this is a vector PQ. Okay, so the coordinates of P is xp, yp. So the coordinates of Q is xq, yq. Therefore, we have to take xq minus xp to get the x coordinate of the resultant vector pq, and then we do the same for the y component. So let's take another example of a board problem in 2 dimensions. So this is the x and y axis. Suppose a boat is positioned at A from the harbor. So let's call this the origin, and at an angle of theta. So the boat now has instructions, so it must move towards the east direction 50 kilometers and reach point B. So from point B, it has to move north 20 kilometers and reach point C. And from point C, have to go there and reach point D. So this is let's put it here. So this is D, and at 20 kilometers. Now, what is the displacement of the boat? So the displacement of the boat is clearly from A to D in this direction. So this is the displacement AD of the boat. So in order to calculate the displacement, we have to add every component of the vectors. So to calculate displacement AD, we have to add the vector AB, BC, CD. So the three vectors are added. So AB vector plus BC vector plus CD vector. And of course we have the components. So AB is in the direction of x-axis. So we take this as a positive direction and positive x direction, and this is a positive y direction. Okay, so it is in the positive x direction, so it is 50, and the y component is 0. It hasn't moved in the y component, so it is 50 and 0, plus BC. So BC is only to the north, so it has moved a positive y direction, so it is 20, but the x direction is 0 here. And plus CD. Now CD, let's suppose CD is at an angle here. Okay, let's suppose this angle is 45 degrees. Okay, so now we have to break this into two components vectors. Okay, so we have this is CD, it is 20, and if this is 45, so we have 20 cos of 45 in this direction, and we'll have 20 sine of 45 in the y direction. Now you have moved negative in the x direction, so it should be negative of this number. So 20 cos of 45, which is 20 times 2 over root, it is root 2 over 2. Okay, if you rationalize this, and this will give you 10 root of 2, but it is in the negative direction, therefore this will be negative 10 root 2. And in the y direction, it is positive sine of 45. Sine of 45 is root 2 over 2 times 20. Okay, so it gives you 10 root of 2, but in positive direction. Therefore, when you add the vectors, you will get 50 minus 10 root of 2 in the x direction, and in the y direction is 20 plus 10 root of 2 in the y direction. So now to find suppose we want to find the angle of theta. Okay, so here to find theta, this is A and this is B. Sorry, D. It's D. So we know that AD, it has in the x direction 50 minus 10 root of 2, and in the y direction it has 20 plus 10 root of 2, and we want to find the angle, let's call it alpha. Okay, so the angle alpha is now given by tan of alpha. If you use trigonometry, you will have tan alpha is equal to 20 plus 10 root of 2 divided by 50 minus 10 root 2. So this will give you tan inverse of this ratio, and alpha is about 43.6 degrees. Now to find the magnitude of AD, we represent magnitude by the bar over here. So this is magnitude of AD. You have to use Pythagoras theorem. So Pythagoras theorem says that this is two components squared. Okay, you add the squared of the two component, 50 minus 10 root of 2 squared plus 20 plus 10 of root of 2 squared. So the Pythagoras theorem. Okay, and then you will get your answer to be about 49.5 kilometers. So AD is 49.5 kilometers as magnitude.